If you read the news lately, you've probably seen three phrases swirling together almost every day: artificial intelligence, machine learning, and deep learning. It can feel like everyone is using them to mean the exact same thing, but they aren't interchangeable synonyms, and they aren't competing products. To understand how modern technology actually works, it helps to picture them as a set of Russian nesting dolls. This diagram from MIT shows exactly how they fit together. Artificial intelligence is the largest outermost box. Inside of that sits machine learning, and nested right inside that middle box is the smallest, most specific layer, deep learning. Keeping this structure in mind makes the rest of the tech landscape much easier to navigate. Let's open the largest doll first. Artificial intelligence is the broadest category. It is the overall goal of getting a computer to mimic human thinking and behavior. For decades, programmers tried to reach this goal by writing incredibly detailed rulebooks. They would type out explicit instructions, telling the computer, if condition X happens, then execute action Y. This rule-based approach worked very well in rigid environments. Take a chessboard, for example. The math is highly constrained. By programming millions of strict rules, computers eventually calculated their way to defeating human champions like Garry Kasparov. But the physical world is not a chessboard. It is messy, unpredictable, and full of strange exceptions. Think about trying to program a self-driving car. You cannot possibly write a specific rule for every single variable it might encounter, like a stray dog running into the street on a rainy Tuesday, while a detour sign blocks the right lane. There are simply too many ifs and thens to code by hand. To solve problems in the real world, computer scientists realized they had to stop writing rigid rules. They needed to build systems that could look at information and learn on their own. That brings us to the middle doll, machine learning. This is a specialized subset of artificial intelligence, where algorithms find hidden patterns in data without being explicitly programmed. Instead of giving the computer a rulebook, we give it a massive, highly organized spreadsheet. We label the columns, like a list of movie genres, directors, and runtimes, and ask the computer to find the trends. This diagram illustrates how the algorithm connects those dots. It compares your history to millions of users. If sci-fi fans also watch a specific documentary, it spots that link. That pattern recognition powers your recommendations, learning the association directly from the data. However, this process still requires a lot of human handholding. A person has to organize that data into neat categories and tell the machine exactly which columns to look at. Machine learning works well for clean spreadsheets. But over 80% of global data is unstructured, meaning it exists as raw photographs, audio recordings, and text documents. To handle that, we need to open the final doll. Deep learning is the innermost layer. It is a highly specialized branch of machine learning, built specifically to process raw, messy, unstructured data. It handles this data using artificial neural networks. You can think of these as multi-layered digital filters, loosely inspired by the way neurons fire in the human brain. When fed a raw image, the first layer of the network recognizes simple edges, and the next detects shapes. Passing data through deeper layers lets the machine identify features on its own, successfully labeling it a stop sign. This ability powers tools like ChatGPT. By learning to identify its own patterns, the machine moves past simply reading spreadsheets and starts demonstrating something that looks very much like human intuition. The underlying math for deep learning was actually developed decades ago. So why are we only seeing this explosion of technology right now? The math had to wait for the physical world to catch up. First, we needed the massive scale of the modern internet to provide enough raw data. Second, we needed computer chips powerful enough to run the calculations. These calculations happen in massive data centers, like this IBM Watson server bank. It takes immense hardware to process thousands of neural network layers simultaneously. If deep learning is the engine of the current tech boom, endless internet data and massive supercomputers are the fuel making it run. So let's put the dolls back together. Artificial intelligence is the broad goal. Machine learning is the method of using data to find patterns, and deep learning is the specialized multi-layered tool used for complex, raw information. There is no magic or science fiction happening under the hood. It is entirely based on applied mathematics and statistics, running at a scale that was previously impossible. And while deep learning gets most of the headlines today, it is still just one tool in the toolbox. Not every problem requires a massive neural network. Understanding how these layers nest together gives you a clear, grounded map to navigate whatever new technology comes next. Now that we have the layout of the land, our next step is to crack open that smallest doll and look closely at the math inside. We're going to explore the surprisingly simple mechanics of how a single neural network actually learns.